Hi everyone. Today we're going to talk about the surface area and volume of 3D shapes. The first one we're going to talk about is the sphere. To draw it, we're going to draw a circle and then kind of draw an oval inside it to indicate that it's 3D. So the surface area of a sphere is going to depend on its radius. We're going to say it's 4 pi radius squared. And then the volume is 4/3 pi r cubed. So these are great formulas to write down for your reference. Next, we're going to talk about a cylinder. The cylinder has two circles as the bases, and it has a height. Now the surface area of a cylinder is going to be the area of the base plus the area of the lateral surface. Lateral surface just means this part that's wrapping around kind of the circle. And how we calculate that is the area of the base is going to be pi r squared. So this area is pi r squared, and then we have two of those, so we're going to put a 2. And then the lateral area is 2 pi r times the height. And the reason this is because if you think about the lateral surface as a rectangle where you kind of wrapped this edge around a circle, then you can see that it's a rectangle where this length is the circumference of the circle, and then this height is the shorter side. And then we know that circumference equals 2 pi r, so that's why we multiply 2 pi radius times the height for the area of this rectangle. What about the volume? The volume of a cylinder is going to be the area of the base times the height. Remember that we had pi r squared as the area of the base, and then h is the height. Now let's talk about a cone. A cone is like this, kind of like an ice cream cone. It has the radius, the height, and then this lateral surface or lateral length that goes like that. We're going to call it S. So the surface area of a cone is going to equal the area of the base, which is the circle, plus the area of the lateral surface, which is kind of the rest of the area rotating around here. The area of the base is pi r squared, our area of a circle, and then the lateral surface is going to equal pi r times S. The volume of a cone is 1/3 times the area of the base times height. Another way you can kind of interpret this is that the volume of a cone is 1/3 the volume of a cylinder with the same radius measurements. So this will be the same as 1/3 times pi r squared, that's the base, times h, that's the height. What about a rectangular prism? A rectangular prism is going to have a length, a width, and a height. The surface area is going to equal the area of all the rectangles that make up this prism. So we're gonna say there's the width times the height plus the height times the length plus the length times the width. And we're gonna have 2 of those because we have 6 sides. 6 times 1, 2, 3 sides. And then the volume of a rectangular prism is going to be length times width times height. Let's talk about the square pyramid. The square pyramid is going to be made up of triangular sides, all with a square base. The measurements that make up a square pyramid are the height, the side lengths of the base, which are the same on all 4 sides of the square, and the sides of the triangles, which we're going to call S. The surface area of a square pyramid is going to equal 4 times the area of the triangles plus the area of the base. So that's going to be 2 times the base length times the height of the triangles plus the area of the base, which is the square's length squared. The volume of a square base pyramid is going to be 1/3 times the base length squared times height. What if we had a pyramid with a different base that's not a square? Let's say we had some hexagon as the base. Finding the surface area would be a similar process where we want the areas of the triangles times, in this case, since it's a hexagon, there's 6 triangles, plus the area of the base. And we're going to assume that we have the base. Let's say it's something like 50 square meters. Then we would know that the volume is equal to the area of the base times the height times 1/3. So we would plug in 50 meters squared right here. The last one we're going to talk about is the triangular prism. This one is going to consist of triangles as the base and rectangles on the sides. We're going to have a couple more measurements. There's going to be the height like before, and then base length, which is this side of the triangle, and then this length, which is the height of the triangle, and then A and C as the other side lengths of the triangle. So just to simplify it a little, you can think of each triangle as having sides A, B, C, and then each rectangle is going to have a width of either A, B, or C, and a height H. So in these terms, we're going to have a surface area equal to the areas of the rectangles plus 2 times the areas of the triangular bases, because there's 2. The areas of the rectangles will be A times H plus B times H plus C times H. And then the areas of the bases are 1/2 times the base times the height of the triangle, which we called L. And then these 2's cancel out, so we can simplify it to say AH plus BH plus CH plus BL. For the volume of a triangular prism is 1/2 times BLH. Let's try this word problem. A homeowner is building a swimming pool and needs to calculate the volume of water needed to fill the pool. The design of the pool is shown in the illustration below. Feel free to pause this video and try this problem on your own before I go over it in 3, 2, 1. So the first thing that strikes me is there's two distinct parts to this swimming pool. There's this top rectangular prism and this bottom rectangular prism. So it might help to draw them as two separate rectangular prisms just to visualize. The top one has a length of 20 feet, a width of 5 feet, and a height also of 5 feet. And we know that because this total height is 10 feet, and the bottom rectangular prism took up a height of 5 feet, so leftover is 10 minus 5, or 5 feet. The bottom rectangle, as we just said, has a height of 5 feet. It has a width of, it seems to be 5 feet as well, and a length of 14 feet. So now we can calculate the total volume. I'm going to call this rectangle A, and then this one rectangle B. The total volume will be volume of A plus volume of B. Volume of A is going to be 20 times 5 times 5, and then volume of B is going to be 14 times 5 times 5. In total, adding those two volumes together is going to equal 850 cubic feet. Don't forget the units because most math tests require you to write them. Let's try another problem. Let's say we have a hexagonal base where the area of this base is 50 feet squared. If this is a hexagonal prism with a height of 15 feet, what is the volume? You might notice that we didn't give a volume formula for a hexagonal prism earlier, but if we apply the logic of our triangular prism, we can see that 1/2 BL is the area of the base, or the area of the triangles. And similarly, for cylinders, the volume formula is the area of the base times the height. For the hexagon, it is a similar story. The volume is equal to the area of the base times height. And luckily we have both of those measurements. It's going to be 50 times 15, which equals 750 cubic feet. Volume is always going to be cubic measurements. Thank you for watching this video. If you have any questions, comments, or concerns, please feel free to leave a comment down below. And if you have any other topics that you want to see videos on, also let me know in the comments. Thanks for watching.